Algebra 2 Common Core series. So this says number 38 because for this chapter I just have a continuous file going, but we're starting off with number 1 here. The sum of a finite geometric series, and we're given this formula, and you are given this formula on your reference sheet on the state regents exam. So it's not one you need to memorize, but it is an important formula. You need to know how to use it well. So the n is still kind of like how many terms we're working with. Like we know when we have like a sub n, it's the nth term. Well, this is sum of n terms, and a sub 1 is still our first term, and r is still your ratio. This is a geometric, so we still have a ratio, first term, and n is n. That's basically it. What makes this somewhat complex is it's a pretty complicated formula, and it's going to require a lot of calculator precision, so we're going to have to type things in and be very careful with parentheses and things like that. So let's see this first example. The sum of the first 8 terms. So first 8 terms, sum of 8 terms means we're doing s of 8, where n equals 8. Now, instead of giving us the sequence as like commas that we're used to, like 3, comma, negative 12, and the comma 48, they're showing it as if we were to add them all together. But this is the same representation as if they were going to write the sequence as 3, then negative 12, then 48, then negative 192, and so on. But if I were to add these together, it would be 3 minus 12 plus 48 minus 9. So sometimes when it comes to a series, we see it actually written out like this. But so anyways, the sum of the first 8 terms. Now, yes, I could figure out the pattern, which I'm going to have to do anyways, but I could continue the pattern until I have 8 terms, because I already have 1, 2, 3, 4, add them up and get the answer. And if the question is that and you want to do that, you can. The only problem is if I mess up the 6th term, then the 7th one is wrong, and the 8th one is wrong, and of course the sum is going to be wrong. And there are going to be questions where, if I want to know the sum of the first 500 terms, that's going to take a while. So we'll use this formula here. So a sub 1 is the first term, that's 3. Parentheses, 1 minus r to the n. Now, r is still the common ratio, and r, if you remember, is any term divided by the previous. How are we getting from one to the next? And most of the time you can tell, like, how am I getting from 3 to negative 12? I'm multiplying by negative 4. So in this case, r equals negative 4. But if I couldn't tell, if it wasn't obvious, I could do any term, like negative 12, divided by the term before it. Negative 12 divided by 3 is negative 4. Now, you want to put that in its own parentheses, the r. Raised to the n, and in this case, n is 8. But it's a little confusing, because if I don't do that, then sometimes people think they can do 1 minus negative 4 and then raise to the 8th. That's not the case, right? It's not the same thing as 1 minus r to the n. It's 1 minus just r is being raised to the n. So you have to be very careful with that. So that's what I mean, like parentheses are a big part of these problems. And then this whole thing is over 1 minus r. Now this is just 1 minus r, so it's just 1 minus negative 4. And really, I'm going to let my calculator do all this heavy lifting for me, but you have to be careful how you type it in. So 3 parentheses, 1 minus, and then an r I'm going to do parentheses, so negative 4 in its own parentheses, raised to the 8ths, and then close that first set of parentheses that had side. 2 open, 2 close. I like to do the entire numerator, get an answer, and then divide by the entire denominator. Some people will try to type the whole thing in at once. That's fine too. As long as you're getting the right answer, it doesn't matter. Some people will do even more piece by piece than I do. Now the bottom here, I know 1 minus negative 4 is 5, so I could just divide by 5. Or if I want to type it in as I see it, now I can't just do 1 minus negative 4. That would be a mistake because it's only going to divide by the 1 and then minus negative 4. So if your denominator is more than a single number, you want to do divided by parentheses 1 minus negative 4. So you're dividing by that whole thing. And that'll get us the answer of negative 39,321, choice C. Let's do one more example. Find the sum of the geometric series. So our sum formula, write it down so we have it. S of n equals a1 times 1 minus r to the n, just r is being raised to the n, over 1 minus r. Now, I have my first term, a1, And I can figure out r here. I see that, how do I go from a ninth to a third? Well, if I'm not sure, I could do any term divided by the one before it. And when I divide fractions, I can change it to times reciprocals. So times 9 over 1. And what we end up here is, 1 times 9 is 9, and 1 times 3 is 3, and that simplifies down to 3. So r equals 3. So times 3 times 3 times 3. So r equals 3. A sub 1 is 1/9. So the only thing I'm really missing is the sum of how many terms. They're not telling me how many terms to add together. They're telling me dot, 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 the last one is 2187. So what makes this question difficult is we have to figure out how many terms this is. And we don't know how many are in between here. So we need to figure out which term 2187 is. Is that the 7th term? Is that the 8th term? What is it? So the way that we're going to do that, again, you could continue the pattern until you get there, but let's use our formulas for practice. We're going to use our geometric explicit formula. A sub n equals a1 times r to the n minus 1. And so a sub n is going to be the 2187. A sub 1 is a ninth. R is 3, figured out. And so n is going to be n minus 1, and that's what we're going to solve for. We're going to solve for n, and that's going to tell us what term 2187 is. And so doing this math here, first, the base is 3. This 1/9 is not part of the base. It's a coefficient, so I'm going to move that first. Divide by a ninth, or, I could think of it as times the reciprocal, so times 9 over 1, which is just 9. That'll get me rid of that. Let's figure out what that is first. Let's do 9 times 2187. 2187, and that is 19,683. So 19,683 equals 3 to the n minus 1. And as we've been doing a lot lately in the past couple of weeks, anytime we're solving for that exponent, we're going to use logarithms. So I'm going to convert this into a log of base 3, because it's always log base, of the answer 19,683 equals the exponent n minus 1. And so let me figure out what that is. And so I'm going to do my math button up to log base 3 of, I could just type second answer since that's the 19, or I could type in 19,683, but either way. So that's going to give me that is 9. So 9 equals n minus 1, and then, of course, add that 1, n equals 10. All right, so n equals 10. So now I know I want the sum of 10 terms. So all of that is just so I can now do my sum formula of sum of 10 terms, where my first term is a ninth, and 1 minus my rate to the 10th, so 1 minus r to the t over 1 minus r. And what does this all come out to be? So let's see. Move this over a little bit so I can see what I'm typing in. So it was 1/9 parentheses 1 minus parentheses 3 raised to the 10th, close parentheses, get an answer, and divided by 1 minus 3. And so divided by parentheses 1 minus 3, or of course you could type, divided by -2. And it's going to give me this answer, which is a decimal, but if I hit math, enter, enter, it may make it a fraction for me. It does. And that's a little bit neater than writing, because this is 4 repeating. So I'd have to do 4 with a little bar over it, which is okay, but this is a little bit better. So 29, 524. Let me see if I keep that up there. 524 over 9. 524 over 9. And that's my answer there. So all of this, oops, move that over. That's my final answer here. All right, so it's a formula that's given to you. It's a lot of just kind of plug and play. Sometimes you have to figure out pieces like we did here, but you have to be very careful with parentheses and be very good at using your calculator. All right, so we'll practice this. So this is series. See ya.